Welcome back. Algebra Express, we are in Rockswold 3.5a, so we're going to start doing transformations of graphs. So we've talked briefly about some of these functions. And so we have a library of functions that we're going to talk about here. So the first thing they give us is the y equals x squared function. So you should sort of know this looks like a parabola. If you were asked to graph this, you should be able to graph this. We're going 1 over 1 up. We go 2 over 4 up. We go 3 over, we go 9 up. And then it's got this sort of reflexive sort of property about the axis. So if I go 1, 1 here, I can go 1, 1 here. And so you're expected to be somewhat familiar with these graphs. And we will do a few graphs with the x squared function. Same thing with this. If I go 4 out, that should give me the value of 2. I'm doing the square root of 4. And so 4, 2 should be a point on this graph. So you should be able to graph these things and know the sort of pattern. If you have to do a T-chart or do a table to get familiar with these sorts of things, then that might be one sort of approach to get familiar with them. But at some point, hopefully you notice there's a certain pattern happening with these things. Because we're going to use these things as parent functions is what we're going to call them. And so these are our parents, and they're going to make little babies that look just like them, but a little bit different. And so the next thing is the cube function. So we will probably use these more so than these. These numbers get really large really quick. So if I'm going at 3, 3's cube is already 27. It's already off our graph. So you should know the general sort of shape of a cube function. So when we cube things, we can have negative values if we cube a negative number, right? That can't happen with a square. They're all positive values when we square something. With the square root, we cannot have square roots of negative numbers. So we do not have any graph over here. Square root is 0, 0, so 0, 0 is a point. Square root of 1 is 1, so 1, 1 should be a point. Cube root looks like this thing laid on end, right? So we should know these sort of linear functions. So y equals x is that one that it goes directly down the middle. It is like that 45-degree sort of line happening here. So it's directly down the middle of the axis. 1, 1, 2, 2, 3, 3, 4, 4. Negative 1, negative 1. All those are points on there. Y equals b is a constant. So we've had this. Y equals absolute value of x. So the absolute value function looks like a v. So I think we've gone through this before. But 1, 1 is a point. Negative 1 is a point. 2, 2 is a point. Negative 2, 2 is a point. And so on. So if you really want to look at it, we can look at this as like being, we can look at these as being 2 lines, maybe. But we don't see like that portion of the line. And if we extend this line, there is like that sort of thing happening, right? That is like the y equals a minus x line. So if we extend those lines, we get this sort of thing. But with just the absolute value, all we're talking about is that little V shape there. Okay. So this is the absolute value graph. They have the absolute value function graphed here. Like I said, 1, 1, 2, 2, 3, 3, and so on with the negative numbers. And so then they have the table here. So if we plug in a negative 3, we do an absolute value of a minus 3. We're going to get the value of 3. And so they want to do the shift, and they kind of tell you what sort of shift it is already, which I'm not really a big fan of. Let's just do it and see what kind of happens is what I like to do. Dive into it. So if we want to do the square root of x, or the absolute value of x minus 4, if x is a -3, then y is going to be equal to the absolute value of a -3 minus 4. So this would be what? 3 minus 4 would give me a -1. So what you should do is you should fill in this table. So you should be able to plug in values to a table sort of like this. Now I'm doing what? -2. So if I do -2, -4 is giving me 2, -4 is giving me a -2. And this is my y value when x is a -2, is a -2. When x is a -1, I'm doing the absolute value of a -1. I'm subtracting 4. This is like 1 minus 4 is going to be a -3. If I'm doing 0 minus 4, that's going to give me a -4. And if I'm doing 1 minus 4, or absolute value of 1 minus 4, I'm doing 1 minus 4, which is giving me a -3. If I'm doing 2, you might notice a sort of pattern repeating here. But if I'm doing 2 minus 4, this is the same actually as what? -2. It would be the same as if you plugged in a -2, right? This would be the same as you plugged in a -1. So it should look sort of reflexive probably. So this is what? -2. And if we plug in 3, I'm going to let you figure that one out, but it should be what? 3 minus 4. I believe it's going to give me a -1. So you should be able to plug these numbers in. I believe we've done this before. This is just evaluating a function at a certain value. Okay. So now we want to graph this thing. 0 minus 4 looks like it's down here. And I'm going to real quick, this is up to 3 minus 1. This one should be coming up to -3 minus 1. So I believe it should be giving us a shape like this. Let me grab my ruler here. A little too far. Ignore that little spot, but we're good. I scribbled a little further than it should, maybe, but it should be that V. And we want to describe what happened to this V shape. So it started up here at 0, 0, and it moved down. Well, I'm already telling you what happened. But what happened is it moved down. And how much did it move down? What effect did it have to subtract 4 from the function? It moved down. And we're going to describe it as moving down 4 units. So we don't know what our units are on our X or Y, but it went down 4. Okay. So we're looking at this. They give us an absolute value of X minus 4, and it shifts it down 4. Now they come back with this question. What do you think the absolute value of X plus 5 is going to do? So subtracting 4 moves down 4, then adding 5. And I don't want to do this, but you could do another table if you really wanted to. But we're hoping you notice a certain pattern, and it moves it up 5 units. So we're going to take the same V, and it would start out like up here. It would be even off the graph, right? We wouldn't be able to do it on this one. We need a bigger graph. And so they give you the summary. So if you add, you're going to go up. If you subtract, you're going to go down. So I will tell you this, the vertical shifts, this is the first shift that we're going to do. These are not super straightforward, but they are fairly straightforward from what you would think probably. If you subtract, you're going to go down. If you add, you're going to go up. So the next thing that we're going to do, you could probably guess we're going to go vertical. The next thing we're going to do is probably going to be horizontal. Horizontal shifts are going to be probably backwards from what you would expect. Let's see. So like I said, hopefully you start noticing a pattern. If I go right 1, I have to go up 1. If I go right 2, I have to go up 4. If I go right 3, I have to go up 9. Right? Same thing here. If I go left 1, up 1, left 2, up 4. left 3, up 9. So I'm hoping you notice that sort of square pattern happening here. And if we can get that pattern down, we can move this thing around. All left, right, up, and down, squish it and stretch it, and do all kinds of wonderful things and flip it. But these are the parent functions, and these are the sort of like patterns that I'm hoping you work with and you will start to understand a little bit better. So with that said, we're going to do horizontal shifts, and I kind of said these are backwards from what you would probably expect is going to happen. So instead of up and down, now we're going left and right, and this says we're taking x minus 1 and squaring it. And so I want to make maybe like a distinction from like what's happening here. So if we were going to move the x squared down 4, we would do x squared and then minus 4. So that would be moving the x squared down 4. So we're looking at whether this thing is inside the function or outside. So this minus 4 is outside my square. Here, the minus 1 is inside the square. So we're asking ourselves, is it inside the function or outside the function? If it's happening outside the function, it's going to be a vertical shift. If it's happening inside the function, that's the thing we're looking at now. This is going to be probably a horizontal shift, since that's what it says. So they do things like this. If you want to do things like this, this is okay. This is probably not the way I would think about it, because I don't think maybe it shows you sort of like what's happening. But if we throw in what, minus 3, I think we're going to get 16. Minus 2, I believe we're getting 9. If you want to do it that way, that's okay. But what I want to think about is we have this square sort of pattern happening. And this is the y equals x squared function. So now if I take the y equals x minus 1 squared, the thing that I'm squaring is not x anymore, but it's x minus 1. So if I take a minus 3 and I square it, I'm going to get 9. So if I let my x minus 1 be these numbers, and I square them, I'm going to get to here. So this is our y values, but we don't have our x values. So what's going to happen is we need to find our x values. So how do we go from x being subtracted to 1 to just x? So if x minus 1 is equal to minus 3, how are we going to get just x? We're going to have to add 1. And same thing, right? If x minus 1 is equal to a minus 2, how are we going to get back to x? We're going to have to add 1. So this would look like minus 2. So for each one of these, we're going to be adding 1. So for each of these, we're adding 1 to this value. So 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. So now I've got a lot of lines on my sort of graph here, or on my table. A marker that might like to maybe. So I don't want like all these lines. I just want to sort of focus on 2 of them. I want to focus on my x and my y. So I'm not really looking at like this line. I'm just looking at that minus 2, 9, that minus 1, 4. That is my x and that is my y. So in order to get to my x, I had to do the thing that was kind of opposite here. So if this thing says minus 1, I have to add 1 to get back to x. So there's a sort of back solving that's happening here. And so I said this was kind of opposite of what you'd probably expect, and we'll see it in a minute. But minus 1 is 4. I can finish up filling my table from what I have here. 0 is going to be 1. 1 is going to be 0. Yeah. 1 and 3 will be 4. 4 would be 9. I wanted to continue this thing. So one of the points is 0, 1. 0, 1 and 1, 0. Sorry, graphed the wrong one. And then 2, 1 is another point. 3, 4. 4 and 9. Same thing here. This thing should be sort of symmetric. So -1, 4 is also a point. -2, 9 is a point. So if we look what happened, we took this thing, and it's kind of warbly, but this is the same parabola. Pretend like it's pretty. So let's move this thing. And how are we moving this? We're moving it to the right one. So subtracting is going to move it to the right. I can't spell right. R-I-G-H-T. It's hard when you don't see what you're writing. Okay. So then they ask us, compare the two graphs and make an observation. What effect did the subtracting one have from the x variable? So if we subtract 1, and this is kind of like I'm saying, if you subtract 1, you might, like, without doing this lesson, you might have said, this is probably going to move it to the left. No, it moves it to the right. Subtracting moves it to the right. Addition is going to move it to the left. So it's kind of backwards from what you think. If it happens inside the function, it's happening to the x variable is one way to sort of think about it. It's like right here on that x, right? It's going to do kind of the opposite. You're going to have to do some back solving. Things are going to be backwards. Up and down is just like you'd think. Left and right is kind of weird. So it is going to move it right, and we're going to say it moved it right 1 unit. This is going to move it left, and we're going to say it moved it left 3 units. And this is the summary that they're talking about. So when they say f of x minus c, this would be like, in this example, our f of x equals x squared, right? So if it's happening within the square, like x minus c squared, that's going to move that thing to the right. That's like the example we had. We had x minus 1, it moved it to the right one. And if it looks like x plus c squared, then it's going to move it to the left. To the left now, y'all. Okay. Now we're going to talk a little bit about a different function. Moving on to the square root function now. Okay, so observing this sort of function and observing this sort of table, if we try to do a square root of a -9, what's happening there? We're doing a square root of a negative number. We're pretending like square roots of negative numbers don't exist right now. We're only in the real numbers. When we talk about imaginary, is the will, but we're only in the real numbers. So don't worry about negative radicals. They don't exist in the real numbers. They don't exist in the real numbers. We're plotting stuff in the real plane, so we can't plot things that are imaginary in the real plane. So they're not getting plotted. Does not exist, does not exist, does not exist. Square root is 0. So square root is 0. And we're about to go into more into square roots. But square root is 0. You can think about it as 0 times 0. And if I have 2 of the same thing in a square root, I can pull it out. So square root of 0 is 0. Square root of 1 is really cheap the same way. I can have 1 times 1 is 1. So I got 2 1s in a square root. I can pull it out. So we can do square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2 times 2. There's 2 2's in the Let's just do it. Square root of 4. I pull out that 2 just once, it comes out as a 2. And so we will go more into that in a later section, I believe. But hopefully you know your perfect squares. And when you take the square root of a perfect square, you're going to get back that squared number, right? 2 squared is 4, 3 squared is 9 is one way you can think about it if you're just confused, right? Okay. So now they're throwing a negative. And I want you to ask yourself, is this negative on the inside or is it on the outside? So the function is y equals square root of x. So it is on the outside of the square root. Contrast it maybe to this one. It's inside the square root. So this is outside of the function. This is inside the function. So let's start with this first one. If we take a negative square root of x, we're going to start with a minus 9. So y equals minus square root of a minus 9. So we're looking at this. We're looking at it again. Look at it a third time, and we notice there's a negative inside a square root. You might notice I can't take that. And I don't want to go through the struggle again. But what happens if we throw in a negative 4? You might notice that's not happening either. This isn't happening either. So it should look sort of like similar maybe to that one. Okay, now we're just throwing in a square root of 0. And I take a negative 0. Okay, that's kind of silly. If we subtract 0, it's still just 0. This is giving me a 0. Now, it might get a little more interesting. Y equals minus square root of 1. Sorry. And I'm evaluating this. Square root of 1 is 1. This is a minus 1. Now I'm doing a minus the square root of 4. Square root of 4 is 2. This is a minus 2. And I'll let you think about this just for a second. This is going to be a minus 3. Let's draw it in the graph above. We have the point 0, 0. We have the point 1, minus 1. We have the point 1, 2, 3, 4, minus 2. And we have the point 4 minus 2, yeah. And we have the point 9 way the heck out there, minus 3. We're never going to do it. So we got those 3 points. What does this thing sort of look like? So hopefully you say it looks like it got flipped. And then you got to tell me how it got flipped. What did it get flipped about? Where did it flip? So it got flipped about this thing right here. It's called the x-axis. So this was flipped about the x-axis. So that's pretty much what they said. They use a sort of more mathematical term probably. The graph is reflected about the x-axis. So reflected is probably a better term. If you want to say flipped, I would give you full credit for saying flipped. It's the same thing, right? They're going to flip it about the x. They're going to reflect it about the x. Okay. And you probably saw what the other one does, but let's figure it out. Do some exploring, see why it happens. So y equals the square root of a minus x. So y equals square root, and the minus is in here. And so the first number I'm going to plug in is a minus 9. So if I do a minus 9, this is the square root of 9. This is going to give me 3. So this does give me a solution here. And you might notice when I plug in a minus 4, the double negative thing is happening again. And I'm getting a positive 2 here. So these are giving me solutions. So y equals square root of a negative x, and x is a -1, double negative, so this is square root of 1 is 1. I'm going to get the square root of a -0. -0 is just 0, so this one is giving me 0. So now I'm looking at this. So when I plug in 1, y equals the square root of a -1. This is giving me something I cannot do. So now this is giving me a negative. Same thing when we try to plug in 4. So when you try to plug in a positive, now it's going to look like a negative, and we can't do these three. Those are giving me, I don't know what those are. I'll have to use my imagination at some point, maybe. Okay. So now we have our numbers. We want to make our graph. -4, 2 is probably the first thing I can graph. -1, 2, 3, 4, 1, 2. -1, 1, 0, 0. And so what did this happen? This was a flip or a reflection. And so we're taking this thing. We're not looking at this one anymore. We're just looking at these two. How did we get from point A to point B? How did we get from this graph to this graph? We took it and we flipped it about this thing right here. This thing is called the y-axis. So this is a flip about the y-axis. So the way or the approach that I sort of think about these things when I look at them is I would look at y equals the square root of x. So if it is outside the function, it is happening to your function value or it is happening to your y values. So these y values were positive. We're going to make our y values now negative. And if we make our y values negative, that's going to flip the y values. So what goes up goes down, what goes down goes up. Flipping up and down is flipping it about the x-axis. The other one, this is like the negative is right on that x. So we're looking at that. That is negating my x values. So all these things going to the right, these positive x values are going to get flipped to negatives. All these negative x values would get flipped to the right. So we're flipping the x values left and right. We're flipping about the y-axis is the way that I sort of think about these things. So we're flipping our x values. This is what happened here. So this 9,3 became a negative 9,3. This 4,2 became a minus 4,2, right? But when you flip one value, you're flipping about the other variable's axis. So we just have a few more graphing problems. I believe that is, well, we'll have one example that might be crucial. But that is the most of the lesson for this part. These are practicing what we've just sort of learned. So if we use this is a x minus 5 squared. Okay, so I want to look at this thing sort of inside out. So this minus 5, I want to see what's happening to this minus 5 first. So if I think about minus 5, this is moving, this is on the inside of the function. So this should be looking left or right. So if I'm looking at minus 5, that should be moving it to the right 5 units. And then now I'm looking at this negative. So I'm going to move it right 5 units. And then this negative is on the outside. So this is just like we had in the previous problem. If it's on the outside, it's happening to the y values. So the y values are getting flipped So this is a flip or reflect. About, and we're flipping up and down, is it going to be about the x-axis? Okay. Okay, so let's draw the like y equals x squared. I'm going to draw it kind of lightly in pencil. 1, 1, 2, 1, 2, 4, 3, 1, 2. Right here. So use this reflexive property to your advantage. This is about where my original parabola should be. And just put it on here, right? 5 units. And then reflect about x-axis. These are the two things that we want to do. So the next thing, I want to remove this right 5 units. So I'm going 1, 2, 3, 4, 5. And I'm just going to do 3 points, 2, 1. And then the last thing, I'm going to draw on some pin. We want to reflect this about the x-axis. This thing, if it's on the x-axis, and you reflect it about the x-axis, it stays there. But these, you're going to go 1 to the x-axis. You're going to go 1 more there. So you're going to go 1, go 1 more. So one way to say reflect or flip is that they are equal distance from the thing that you flipped it. So this, you're going 4. You're going to go -4 down here. 1, 2, 3, 4. Use that it's reflexive to your advantage. This one should be at 9. It should look something like this. And again, I put middle steps in here. I'm not necessarily expecting you to write out the middle steps if you understand what's going on here. If you have to write out a table and you want to write out a table for these things to get a handle on these things, that's good. But like at some point, hopefully, we're hoping you start noticing these sort of patterns happening. Okay, and then a good sort of tool if you want to sort of check. Let's see if we can go to it. Is Desmos here. So if you look at this, you got to type things in correctly, but y equals what? There's a negative, and then there's an x -5, and we do the little raise, the ampersand, I believe it's not an ampersand, caret is what it's called. And that looks hopefully just like the thing that we just drew. It is on 5, 1. There's some other points we could probably pick along here. 4 -1 was another point. 6 -1 would be 6 -1 would have been a point. It's right there. Okay, so you can always use like technology to sort of check, probably not on a test, but if you're trying to get a hold of these things and see what they do, that might also be a good way because you can always just like sort of plug in numbers here and play with it, right? So I know you just want to play, but you can also put sliders. You can learn how to animate things if you want to animate things on here. Look at that. We can do like a minus, I don't know, A, who knows? I'm getting ahead of ourselves probably a little bit, but you can do a lot of funky things. So stop sharing this. Let's go back to here. And we have this thing that looks like the square root of x +1 -3. So we want to look at the parent function here first. The parent function is the function that looks like y equals the square root of x. So that's the thing that we're thinking about. It goes whooshoo. If I want to draw that, let's go ahead and draw that pencil. So 0, 0 is a point, 1 is a point, 4, 2 is a point, and find the point and they look something like that. So that is our original function. We want to think about what these things are going to do. So I want to look inside here first. I see x plus 1. And I see a minus 3. And hopefully you notice this is outside the square root. So one of them is inside the function. This is outside the function. So things inside the function are going to move the x, which goes left and right. So a plus 1, this is going to move it left 1. A minus 3, this is happening on the outside, so these are our ups and downs. So this is going to move it down 3. So I'm probably going to do this one all one swoop. So if I take this point, I can move this thing sort of point by point. So if I go left 1 and go down 1, 2, 3, here's my new point. There's my new starting point. I'm going to move left 1 and down 1, 2, 3. And I'm going to move this one left 1 and down 1, 2, 3. And I'm going to move this one left 1 and down 1, 2, 3. So my new function should look like that. So it went left 1 and it went down 3. And again, if you want to use technology to sort of check that you're getting these things correct, that's a good sort of thing to do, right? Okay. So we just have a few more examples, but this one I feel like is pretty important. You probably see a few of these. So my suggestion is to write out the points that you see first. So this is a minus 1, 2, 3. This is a minus 3, comma 0 is my first point that I see here. This is a minus 1, comma 2. And then the next point I have is 1, 2, 3, comma minus 2. So this is my function. If things are happening, this looks like outside the function. This looks like something is happening inside the function. So if you want to use graph transformations, we can look at this thing. This should be happening to my y values. So if I'm thinking about this, this is happening to my y values. I'm flipping the y values. That's going to be a flip about the x. And then this plus 2 is going to move it up 2. Okay, so that is one way you can approach this problem. The other way is that this is happening to my y values. So if I know the point, like minus 3, comma 0, we can focus just on, let me get another color, just this y value here. So what I'm going to do is I'm going to put a negative on here. So I'm going to, let me get another paper right here. I'm going to do a negative 0 plus 2. That's going to give me my new y. So negative goes to 0. This is going to give me 2. So another point I can put on here for this graph is a minus 3, comma 2. I can look at just the y value here. So I put a negative on a 2, and then I add 2 to it, is going to give me 0. So minus 1, comma 0. So if you want to do these point by point, this is a way that you can do them. So now I'm taking a minus 2, I'm putting a negative on it, which gives me 2, and I'm adding 2, which gives me 4. So 3, comma 4, This is one way you can do it. Or you could do it with the graph transformations, like I said. So you can do them point by point, or you can do them with graph transformations. So if I plot these points, minus 1, 2, 3, 1, 2, that's the same as if I took this point, I flipped it about the x, it's going to stay on the x-axis, and then I move it up 2. This one, if I flip it about the x and then move it up 2, it's going to come out to minus 1, 0. Same thing with this. If I flip it about the x, then move it up 2, it's going to come out to 3, 1, 2, 3, 4. So this whole thing got flipped about the x. So the orientation is going to be a little bit different. Instead of a downward check, it's going to flip it to like an upward check. And then we're going to move it up 2. Okay, so that one had 2 operations on it. This one is a little bit easier. Now we're flipping the x values. So if we flip the x values, it's going to flip about the y-axis. So we're swapping the x values, we're negating the x values. So you can flip this thing about the y-axis. Everything gets flipped about the y-axis. This comes over here, this comes over here, this goes over there. Another way is you can take it point by point. So we're throwing a negative on the x value. So instead of minus 3, 0, this is going to be 3, 0. Instead of minus 1, 2, this is going to be 1, 2. Instead of 3 minus 2, we can do a minus 3 minus 2. So 3, 0 is taking place at this point, getting flipped about the y. 1, 2 is this point getting flipped over. And then minus 3 minus 2 is here. That is that point getting flipped. This should look sort of like that. And they leave you one last problem to do. So again, the parent function, you want to recognize the parent function. Square root function. That one's too high. Do that in pencil. That's my parent function, the square root function. 0, 0, 1, 1, 4, 2, 9, 3. Now I'm looking at the shifts. What does this thing do? This thing moves it left 1 unit. What does this thing do? That's on the outside. That's going to flip my y values. It's going to flip my y values about x-axis. So we're flipping about x-axis. So I'm moving it left, and I'm flipping it. It's going to stay on the x-axis. I move this thing left 1 unit, and I flip it. It's going to come down here. I move this left 1 unit, and then I flip it. I move this back left 1 unit, and I flip it. Should be looking something like that. And we will have one more section on graph transformations. And then we'll start doing more stuff on quadratics. So I will see y'all soon. Take care, study hard.